Hi, I'm Caroline.
And I'm Neil, and welcome to another edition of Tiny Robotics Virtual Outreach content. Today, we are going to show you how to make rubber band flying cups and the science behind how they operate. Now, let's get started.
Cup. All you need are 2 plastic cups, some duct tape, and a handful of rubber bands. First, what you're going to do is take the cups and put them end to end like this. Then, take some duct tape, or whatever strong tape you're using, and stick them together, wrapping it as tightly as you can so that when you pull them in the end, they don't come apart. Like this, now they're stuck together. Now what we have to do is make a rubber band rope. This one I have here is 4 rubber bands, and it works for these cups. Depending on which cups you use, you might need more or less. We found 4 is about optimal. So to make the rubber band rope, you take some rubber bands like this, and you pass it through so that one is sitting on it like that. Then you pinch through, kind of like that, pull it through the hole, and then pull to tighten. You have to then continue. So pass it so that it's hanging like that, pinch through, and pull it back through the hole. So just continue until you have the right size rope for your flying cups.
You can also use plastic containers. However, it will change the amount of rubber bands you'll need to form your line, and obviously the size of the rubber bands needed to get the proper optimal operation.
And then you shoot!
An interesting one to know is that you can change the flight path of the flying cup by either manipulating the position of the cup and the rotation used with the rubber band line before launching it. But why do these variables change the flight path of the cup? Well, that can be explained through a concept known as the Magnus effect, named after German physicist Heinrich Gustav Magnus. But what is the Magnus effect? Well, Britannica defines it as the generation of a sideways force on a spinning cylindrical or spherical object immersed in a fluid, liquid or gas, when there is a relative motion between the spinning body and the fluid. In layman's terms, it is a force perpendicular to the rotating axis of a spinning circular object. In the context of the flying cup, the direction of the Magnus force is dependent on the rotation done by the rubber band line. If, for example, the line is wrapped clockwise, the force is coming from the top, causing the cup to fly down after being launched. In another example, if the line is wrapped counterclockwise, the force is coming from the bottom, and the reverse effect happens, where the cup will initially fly up before going down. Due to Earth's gravitational forces, the flying cup's path for either scenario ends on the ground due to Earth's gravity having a stronger magnitude of force.
Another scientific topic demonstrated by this flying cup is the difference between potential and kinetic energy. Potential energy is stored, so when I stretch this, the rubber band has a lot of potential energy, but when I release it, it all turns into kinetic energy and the object turns into motion. So potential energy means that the object has the potential to do something, whereas kinetic energy is the energy of it in motion. In the context of the flying cup, when you wrap this rubber band really tightly around the cup, you're creating a lot of stored potential energy. But when you let go, it all turns into kinetic energy and makes your cup fly through the air.
Thank you for watching this video. Make sure to like, subscribe, and tap the bell icon to stay tuned for more Tiny Robotics Virtual Outreach content. In our next video on Friday, members Akiva and Caroline Gill will be covering various stereotypes surrounding high school robotics. Make sure to stay tuned, and have a good afternoon, y'all. See ya.